As the complexity of software applications grows, there is also a rise in the number of interfaces between different systems. This leads to an ever growing API footprint, an explosion of integrations between clients and servers. Ultimately, this results in a maintenance nightmare. Even minor changes start taking more and more time to implement. You need to analyze more, test more, and even then, there are chances that issues might creep into your application. More often than not, refactoring appears to be the only solution to handle the ever growing maintenance costs. However, refactoring is a costly business, and usually it does not get management approval unless there is a very strong reason to do so. So, what is the solution to this tricky problem? This is where GraphQL steps in. GraphQL is a tool that brings paradigm shift in the way clients and servers communicate with each other. While it is not a silver bullet by any means, it can definitely act as a sweet spot between a complete overhaul of the application or doing nothing at all. Have you still not subscribed to the channel? Then what are you waiting for? You don't want to be missing out on any future videos of CS Tracker. Subscribe now and don't forget to press the bell icon. As per Wikipedia, GraphQL is an open source data query and manipulation language for APIs. It is also a runtime for fulfilling queries with existing data. In a sense, GraphQL stands for Graph Query Language. But don't let those words mislead you. GraphQL is not like SQL. While it may be dubbed as a query language, we don't query typical database tables using GraphQL. GraphQL is more of a format or a structure to define the contract between the client and the API server. Basically, you can think of GraphQL as a specification or a new API standard similar to REST. However, it is often considered more efficient and flexible when compared to REST. In fact, we can practically use GraphQL wherever we were using REST. In a way, GraphQL aims to do what REST was doing, only in a much better way. So, how did GraphQL really start? GraphQL was initially developed as an internal project at Facebook sometime in the year 2012. According to the co-creator of GraphQL, Lee Byron, the concept of GraphQL emerged when they were trying to design a native iOS newsfeed using RESTful APIs. They immediately encountered a bunch of issues. The API requests were slow on the network, coordination of requests for different models was problematic, multiple round-trip requests had to be made on flaky mobile connections, API changes had to be carefully carried over to the client code to prevent the app from crashing, API docs were often out of date from the actual implementation. It is said that necessity is the mother of all inventions and feedback is the father of all improvements. The goal of overcoming the challenges caused by using normal RESTful APIs led to the birth of GraphQL. GraphQL was publicly released in 2015, and ultimately in 2018 the GraphQL project was moved from Facebook to the newly established GraphQL Foundation. Currently, the GraphQL Foundation is hosted by the non-profit Linux Foundation. At this point, you might be wondering how GraphQL works and what makes it so special. Think of a vending machine. To get an item from the vending machine, we press a button and we get one item. To get the second item, we press another button. If we have to get 10 items, we press 10 different buttons. This is how the RESTful API approach works. For every piece of data, the client needs to make a new request. Needless to say, the process is slow. To get around this inconvenience, the traditional approach has been to create special endpoints. Think of it as a vending machine having special buttons to get a combination of items. Every special button handles a particular combination of items. The problem, however, does not go away. How many special buttons would you create? There might be hundreds of combinations a user might be interested in. Even if you create 100 special buttons, you can never be sure that the customer might not look for a new combination. Clearly, this approach is not suitable. There is a third approach as well. What if the vending machine supported an option to choose multiple items by pressing a combination of buttons? Basically, the user tells the machine exactly what it needs, and once that is done, you get everything in one go. This is the essence of how GraphQL works. A GraphQL API depends on what the client actually needs. The client specifies exactly what it needs, and the GraphQL server provides everything in one go. This is unlike RESTful APIs, where the server controls everything and the client has to often make multiple requests. Now that we have a basic overview of GraphQL, it is time to look at some important features of GraphQL. Point number one, GraphQL is declarative. In GraphQL, clients ask queries to the server. These queries are declarative in nature. A typical GraphQL query may look like this. It is pretty self-explanatory. Basically, the client is asking for the book with ID of 1. Also, the client is specifying that it is only interested in the fields title and publish year. The GraphQL server has to make sure that only the fields specified within the query are returned as part of the response. As you might notice, this is a totally different approach from REST API design. In REST API design, the client has very little control over what gets returned from the server. Second point, GraphQL queries are hierarchical in nature. In this example, the client is asking for the book with ID of 1. However, along with the book, the client is also interested in getting the author-related information of the book, especially the name of the author. In GraphQL, queries can describe this type of hierarchical relationship quite easily. The third feature is type safety. In GraphQL, we have to declare schemas to specify our data models. A GraphQL schema helps the server determine whether the client's query is valid or not. These schemas are strongly typed. A basic schema looks like this. Each attribute in the book type has a data type of its own. The type system can use primitive types such as numeric integers, booleans, and strings. However, it is also possible to use complex types such as objects. Apart from the features, there are certain core concepts of GraphQL. These core concepts form the backbone of GraphQL and it is important to know about them. Number one, we have the Schema Definition Language or SDL. As we saw earlier, GraphQL has a type system. It is used to define the schema. Basically, the syntax for writing the schema is also known as the Schema Definition Language or SDL. A very simple schema may look like this. This schema describes an author. It contains only one field, the name of the author. The exclamation mark here denotes that name is a mandatory field. Concept number two, we have queries. Queries are arguably the most important concept of GraphQL. Clients make queries to the GraphQL server. These queries specify the requirements of the client. If the query is found to be valid, the server sends a response. This is an example of a typical GraphQL query where we specify the ID of the book and the specific fields we want to fetch. The third concept is known as mutations. As we all know, APIs are used not only to query information but also to update information. In GraphQL, updates are supported using the concept of mutations. A mutation looks like this. As you can see, the mutation syntax looks quite similar to the query syntax. However, the mutation keyword makes the GraphQL server aware that the client wants to perform an update or create operation. The fourth concept is subscriptions. In many modern applications, it is important to have a real-time connection between server and client so that the client can be immediately informed about important events. Subscriptions don't follow the typical request-response cycle. When a client subscribes to an event, it will hold the connection to the server. When a particular event occurs, the server pushes the data to the client. In GraphQL, subscriptions are also written using the same format as queries and mutations. Once the client sends such a subscription request to the server, a connection is opened between them. Whenever a new mutation happens that results in the creation of a new author, the server sends the requested information to the client. Now that we have a pretty good idea about the features and concepts of GraphQL, it is time to see GraphQL in action. And to do so, let us start with creating a very simple GraphQL API server. Basically, there are three things a GraphQL server needs to work properly: a web server, GraphQL schema with a resolver, a request handler to process incoming requests. First, for the web server part, we will use Express, a popular NodeJS framework for building APIs. Second, the schema and resolver are handled by the GraphQL package. This is a standard GraphQL implementation for JavaScript and forms the basis for other sophisticated implementations. Lastly, for the request handler part, we will use the Express GraphQL package. This package is basically a middleware for Express that helps us handle incoming requests. In the first step, we will create a project directory and install the required packages. For any of this to work, you need to have Node.js installed on your system. Next, we create a file named server.js inside our project and place this code in that file. Let us walk through what's going on in this particular code. After the necessary import statements, we define the schema using the build schema function. Then we specify the root query and register one query type named hello. Next, we set up the Express app and implement a request handler to handle incoming requests. Within the request handler, we configure the GraphQL HTTP middleware to use our schema and the root query. A typical GraphQL server usually has only one endpoint. All queries are processed by the same endpoint, unlike REST APIs, where each resource has its own endpoint. Here, that single endpoint is GraphQL. The GraphIQL flag is set to the value true. This flag enables the GraphQL user interface for our application, where we can play around with the queries and see the responses from the server. We can access the UI on HTTP localhost 4000/GraphQL. Having seen a working demo of GraphQL, we are now in a position to compare GraphQL with REST APIs. There is no denying the fact that REST has been an industry standard for the past several years. However, REST APIs are often inflexible and don't adapt well to the changing requirements of the client. This is where GraphQL offers benefits when compared to REST APIs. The first major problem with REST is that you end up overfetching data. This is because in the REST approach, each endpoint has a specific layout. Even if the client needs only one field from that layout, the API will return all the fields, whether you like it or not. This results in overfetching of data. While overfetching is a problem, there is another bigger problem with REST, and that is underfetching data. It is quite common that a single API endpoint in a RESTful approach does not provide the complete information that is needed by the client. We make an API call, get some response, and use that response to make another API call to get the rest of the information. Depending on the design, there can be multiple calls to accumulate required data. This is also known as the n plus 1 problem. This illustration demonstrates the n plus 1 problem where we have to make multiple calls to fetch the book and the author details when following the REST approach. In GraphQL, this problem does not occur. This is because the clients can write hierarchical queries with nesting information. Going further, REST APIs can lead to unnecessary network traffic due to multiple API calls. In other words, more data goes over the wire. In the case of GraphQL, the same amount of data can go through a single call using proper hierarchical queries. Lastly, with REST APIs, it is hardly possible for the server to determine what the client is doing with the data and what fields it is actually interested in. The server simply sends everything and forgets about it. In GraphQL, clients send specific queries. Imagine the use of this information from an analytical point of view. Monitoring of GraphQL queries can result in future improvement to the API offerings, depending on what kind of queries are being asked by the client. As we have seen till this point, GraphQL is extremely flexible. Due to this reason, it provides a lot of flexibility when it comes to the architecture of your application. On a high level, GraphQL follows the typical client-server architectural pattern. The client makes a request and the server provides a response. However, there can be several variations in terms of how to structure a GraphQL server. First, we have the GraphQL server with a connected database. This architectural pattern is most suitable if you are starting a brand new project, basically something like a greenfield project. In this setup, we have a single web server. This server implements the GraphQL specification as per the core concepts of GraphQL. When a query is received, the server resolves or processes the query and returns a response. Though we have marked the transport protocol as HTTP, it can use any other protocol as well. This is because GraphQL is transport layer agnostic. Also, GraphQL Server can connect to any database solution such as MySQL, MongoDB, or AWS Aurora. The advantage of this approach is low complexity in terms of data fetching. The data source is also close to the application logic, due to which there is less latency. If possible, this is an ideal pattern to use. However, it is possible only in the case of a new project where everything is done from scratch. In an existing application where we want to utilize existing parts of the system, we need to examine some of the other patterns. Second, we have the GraphQL layer with existing systems. GraphQL provides a lot of flexibility to the client in terms of building a query and requesting for information. However, an existing system might already be built using different solutions such as third-party APIs, legacy services, and a bunch of newer microservices. Considering this, one might assume that we cannot use GraphQL in such a scenario. But this is an incorrect assumption. As you can see, GraphQL can unify the existing systems and hide their complexity behind a unifying GraphQL API. New client applications can simply interact with the GraphQL API without worrying about the underlying systems. The GraphQL server will be responsible to resolve the queries and package the responses as per the client's requirements. This approach can suit a lot of big organizations where a large number of existing services are already present and it is time consuming and risky to duplicate the business logic for new requirements. The third pattern is basically a hybrid approach. It is a combination of having a connected database as well as talking to existing legacy systems. In this approach, when the GraphQL server receives a query, it will resolve it by retrieving the data from the database or talking to one of the services. This approach can also pave the way for slow migration of business logic from legacy systems to the new GraphQL servers. One could incrementally put more and more functionality into the GraphQL server and connected database while slowly deprecating old services. Finally, it all boils down to the advantages and disadvantages of GraphQL. This particular section is important because these are exactly the points that may help you decide whether you want to use GraphQL or not. From an advantage point of view, we can say that the API clients get way more freedom with GraphQL. The client applications can formulate queries depending on the requirements without being extremely dependent on the server. Since GraphQL uses schema definition language based on type safety, it provides an automatic layer of validation. Developers consuming the GraphQL APIs can easily see what the schema supports and accordingly formulate the queries. From a disadvantage point of view, since GraphQL supports hierarchical queries, complex queries with a lot of nesting can often lead to performance issues. To avoid these issues, we might have to implement rate limiting or nesting limits to our GraphQL queries. While GraphQL is a great tool to reduce complexity, it might even be an overkill for small applications. For a simple application, a REST API might be a better option. GraphQL does not support HTTP web caching. At the end, it is important to note that GraphQL is a wonderful tool to build APIs that are adaptable to evolving customer needs. If your application's API footprint is growing out of hand and you have got a bunch of disgruntled consumers complaining about the need to call multiple endpoints to get what they need, it might be a good idea to explore GraphQL. Also, if you're looking to build APIs without needing to constantly push out new versions while maintaining older versions, GraphQL is again a great choice. That was actually all about GraphQL in this particular video. Hope this video was useful in some way. If it was, please do like and comment, and also don't forget to subscribe to CS Tracker and press the bell icon. See you in the next video and stay safe.